गुड इवनिंग फ्रेंड्स, स्टडी विद अपाला इंजीनियरिंग एंड जर्नल जियोलॉजी परवीन सिंह बुक। तो हम चैप्टर 10 पढ़ रहे हैं, द स्टडी ऑफ मिनरल्स। 9 में भी मिनरल के बारे में था, काफ़ी लेंदी सब्जेक्ट भी है। तो आज का टॉपिक है एन एक्सेस ऑफ सिमेट्री। इट इज़ डिफाइंड एज एन इमेजिनरी लाइन इन a crystals passing through its center in such a ways that when a crystal is given a complete rotation along these lines, a certain crystal face taken as a reference face comes to occupy the same position at least twice. In fact, it may occupy the same positions more than twice also. The angle of rotation need to bring a reference face to the same position so that it's to repeat itself define the nature of the axis of symmetry into one of four types. Axis of binary or twofold symmetry. This requires that the crystals must be rotated by an angle of 180 degree to bring the reference face occupy the same position. In other words, and so when the crystals is rotated about such an axis, a given face makes its appearance only twice in one completed rotation. Axis of trigonals or the threefold symmetry. It is that axis imaginary lines on which crystals must be rotated by an angle of 120 degree for a reference face to occupy the same positions again in space. In other words, a reference face make its appearance thrice in one complete rotations about such an axis. Axis of tetragonals or fourfold symmetry. It is that axis on which the crystals must be rotated by an angle of 90 degree to bring a reference face in the same position in space. Obviously, in such a case, the reference face will occupy the same position at least four times in one's complete rotations. Axis of hexagonal and six-fold symmetry, in which a rotations of 60 degrees required to fulfill the conditions of repetitions of a reference face. In such a case, a reference face will appear six times in one's complete rotation about the axis. In a given crystal, there may be possible one or more axes of symmetry, some of which may be of binary natures, others of trigonals or tetragonals nature, and so on. The highest number of axes of symmetry is 13, observed in normal class of isometric system. Center of symmetry. Of a symmetry. If one passing in imaginary lines from some definite face, edge, or corners on one side of the crystal throw is the center. It's the center. Another exactly similar face or edge or corners is found on the other sides at an equal distance from the center. Many crystals have no planes or axis of symmetry but do possess a center of symmetry. In other cases, the center of symmetry may not be there, whereas the crystals may be symmetrical to a plane of symmetry. Crystallography axis. These are also termed as axis of reference, and simply certain imaginary lines are arbitrarily selected in such a ways that all of them pass through center of an ideal crystal. The concept of axis of reference is based on the fact that exact mathematical relations exist between all the faces on a given crystals with reference to its center. It has been therefore possible to define their position with reference to these assumed straight lines passing through the center of a given crystal. In crystallography, following general assumptions have been universally agreed upon regarding these crystallographic lines. Three straight lines essentially is passing through a common center and varying in mutual relationship with respect to their length and angular inclinations from all equals interchangeable and are at right to all unequals and inclined with each others. Four straight lines and essentially passing through. ये प्रैक्टिकल में बहुत काम आती है, ये एग्ज़ाम में भी आता है, तो इसकी प्रैक्टिस आप ज़रूर करिएगा, क्योंकि थ्योरी तो तभी समझ में आएगी जब आप डायग्राम को समझेंगे कि कौन से डायरेक्शन से कैसे रन कर रहा है. तो essentially passing through a common center and varying in mutual relationship with with respect to their length and angular inclinations from all equals interchangeable and at right to all unequals and inclined with each other. Four straight lines in essentially passing through a common center on the verticals being unequal to the other three but at right angles to them. The three horizontal axes are separated from each other at 120 degree. The concept of crystallographic axis has been the basis of classifying all the crystalline substances into six crystal systems as described later. Whilst fixing a crystal in its studies position with the reference to the crystallographic axis, it is important to align it is such a way that one of the axis runs front to back and from the observer, another runs right to left, and one is passing from top to bottom of the crystal. Obviously, in such a case, each of the three or four axes will have two ends and which must be distinguished by some conventions. It is the usual practice to distinguish the axis running from front to back as a1 axis and its end nearer the observers as a plus, whereas the further end is marked minus. The second axis running from the right to left is designated as a A2 axis if its length is same as that of the first axis. Otherwise, it is designated as a B axis. It will be given plus signs on its right terminus and minus signs of the left terminus. Similarly, so the vertical axis may be designated simply as A3 if it has the length equals to the others two. Otherwise, it is a C axis with the plus signs placed at the top and minus signs at the bottom. So in figure, clearly we see. Thank you.